All right, chemists, so I want to talk briefly about alcohol classification. So classification of different organic compounds within one family often comes down to how things are structurally related. So alcohols are classified based on the number of alkyl groups. So that's really another way of saying carbon groups, carbon-based groups like our methyl and propyl, sorry. Alkyl groups attached to what is called the carbonyl carbon. So notice that we have that weird OL here at the end, right there. So we've got OL. So what that means is that we have a carbon that is directly attached to the hydroxyl group. So this is the name of the functional group of alcohols. You'll notice sometimes the functional group has its own name. So this is a hydroxyl group. The carbonyl carbon is the carbon that is directly attached to the hydroxyl group. And so the different classification systems that we're going to see, we're going to classify them as either primary, another way to write that, secondary, or tertiary based on what else this carbon is attached to. So not based on what the hydroxyl group is attached to, but based on what this special carbonyl carbon is attached to. And essentially it comes down to primary means it's one alkyl group. So R, which I always think of as the rest of the molecule. So that means one carbon group. That would make these hydrogens. Secondary is going to be two alkyl groups instead, and tertiary, whoops, I was going to do a 3 instead, would be 3. So let's take a look at some examples of those. So here we have our generic looking one here where we don't have any idea what that R group might be. It could be a propyl group or an ethyl group, you know, a longer carbon chain. But it's not a hydrogen in this case for sure. So here we have the generic form for a primary alcohol, and then we have the ball and stick model of a specific example. So we have ethanol here, so 2 carbons, that gives us the eth, and then we have the carboxyl or the hydroxyl group there, and then that would make, if I can find my pen, that would make this then the carbonyl carbon. So since the carbonyl carbon is attached to one carbon, it is a primary alcohol. In this case, with our 2-propanol, also known as isopropyl alcohol, we see that the hydroxyl group is on a middle carbon. So this is our carbonyl carbon. I'll put a little C there, and you'll notice it's attached to 1, 2, therefore it's secondary, and so on and so forth. And methanol, our simplest alcohol, sometimes is considered to kind of have a class of its own. Some people will consider it a primary alcohol. It reacts very similarly to a primary alcohol, and so I kind of lump it in there, but it is not technically a primary alcohol because none of the attachments to the carbonyl carbon are alkyl. They're all hydrogens. So let's do some quick practice. I'd encourage you in any case like this to pause the video and try to do it on your own. And then if you get stuck, to play until you get unstuck, or to check your work. Okay, so we're just looking to classify. So starting with A, what's the classification system of this? So we're essentially classifying as primary, secondary, or tertiary. So for what I would recommend doing then is locate your carbonyl carbon, maybe outline it, put a star by it, something, and then consider what things are attached to it. So one thing to remember, and sometimes it helps to just kind of mentally redraw it or draw it over here. So this carbon is attached to this hydrogen. So I know it's attached to one other hydrogen. So that tells me it's not tertiary, but it is attached to this carbon and this carbon. So this is a secondary alcohol. We'll go alphabetical order because that makes the most sense. Down here at B, find your carbonyl carbon. Here's my carbonyl carbon right there. And if I look, I see that it is attached to this carbon, and this carbon. I know it looks like it's attached to this hydrogen, but that's kind of the part of translating these formulas into their 3-dimensional shapes. This hydrogen is actually branched off of this carbon. So since it is attached to 1, 2, 3 alkyl groups, it is a tertiary carbon. Over here, I actually see that ethanol. We just took a look at it on the other slide, so you might even remember it is a primary carbon because the carbonyl carbon is attached to only one other carbon group, so one alkyl group, so one or primary. And then even if you have a cyclic structure here, we have to kind of think, what is that carbon attached to? So here's my carbonyl carbon, so I'm going to highlight it, and it is attached to, it's kind of weird because the structure loops back on itself, but it's technically attached to two alkyl groups. It's attached to this carbon going this way and this carbon going this way. So this cyclic structure would be classified as a secondary alcohol. Now these are all really similar structures. We might have to do a little bit more thinking if we were, say, looking at a structure that was a line formula. So if I were looking at this, I'd have to kind of, there's some implied hydrogens and I have to think about that. We see though a really similar structure to here. Here's my carbonyl carbon and it is attached to this alkyl group and this alkyl group. So the fact that they kind of loop back on themselves doesn't change that counting, and this would be a secondary carbon as well. So let's talk naming real quick. So first, let's use these to start the conversation on naming. Looking at those exact same ones, you can see their IUPAC names listed there. 2-butanol, ethanol, 2-methyl-2-pentanol, and cyclobutanol. So a couple things to note real quick before we get into the nitty-gritty details of naming. You'll notice probably right away that this OL, which we also see here in the name and can be a helpful kind of memory tip then, is going to be the ending of our IUPAC name. So instead of ane or een or ein, we're going to have that OL at the end. We're still going to be counting carbons using that kind of generic prefix that we've seen. You'll notice if it's cyclic, we're going to use cyclo to clarify that. We're going to be identifying substituents. That pattern and those rules are all going to be really similar to what you learned before. So that's kind of helpful if you get really good at the foundational rules. We're just building off of them from then on. You'll notice that sometimes we do need to locate that hydroxyl group. That's what this number is about here and here. And it is left off these two, no number, because it would be understood to be on carbon 1. And we see that with the cyclic structures in alkanes too. Carbon 1 is whatever carbon has the special group. And with ethanol, both carbons are technically considered carbon 1 depending on how you count, so we don't need the 1 in that case. So let's look at some more complex examples. We'll start with this and go through kind of the generic naming rules. And some of these are going to sound really familiar because the first steps, the foundational steps, tend to be really similar for all of these compounds. So naming alcohol, step 1, name the longest chain with the hydroxyl group. Okay, the key word there, or words, is right here. The carbonyl carbon needs to be a part of the chain. So you have to kind of, this one's pretty straightforward because it's all just one line, but do consider your branching, and the carbonyl carbon does need to be one of those carbons. So if it branches off a different direction and doesn't include the hydroxyl group, go back and recount in a way that makes sure you have the carbonyl group in that chain. So this one's pretty, none of that have to consider. 1, 2, 3, 4, 5, 6. So I know that I'm going to be going with hex, right? So hex. Now if this were a saturated hydrocarbon, I would name it hexane. But in this case, I'm going to drop the E and replace it with OL, just like I see in the word alcohol. So that makes that then hexanol. Next step, number the longest chain to give the lowest number to the carbon with the attached group. So our hydroxyl group is getting that preference. So if I count from this way, I'm going to get 1, 2, 3, 4. Well, that sounds like too many in comparison, so let's count the other way. 1, 2, 3. So I'm going to have to locate this on the third carbon, and counting from the side closest gave me the lowest number. So then I locate, so that means to put the number in. Put the number in. 3 hexane, oh, whoops, I put it on the wrong one. 3 hexanol, and for this one, that's really our final name. Now, if you go around the internet and you're looking for extra resources, you might see that sometimes there are certain ones that will do hex 3, must be hex and 3 all. So I want you to, I'm not going to ask you on that, but if you see that, it's just a different way of putting the number in a different position. This is the system that we're going to use. This is a little bit more IUPAC. So we're going to put the number in front here, identifying and locating the hydroxyl group. So let's look at another one to kind of continue on with some steps. So if we were going to name this, so this has that hex. It's 1, 2, 3, 4, 5, 6, right? And the hydroxyl group's still on the third, so I'm still really dealing with some variation of 3-hexanol. But if I have other substituents, I need to locate and name them accordingly, right? And then combine it all to give the overall name. So in this case, I've got 2 methyl groups right there. So that's going to tell me, okay, I'm going to have dimethyl. 1, 2. And I'm going to stick with that 3 because that gave the hydroxyl group the lowest number. So 1, 2, 3, 4. So this is going to be 2, 4 dimethyl 3-hexanol. Go ahead and ask yourself what classification of alcohol this is. You probably recognize that it is a secondary alcohol because our carbonyl carbon is attached to 2 carbon groups. So 2,4-dimethyl 3-hexanol. So what about if I wanted to give the IUPAC to this molecule? So the common name of this is glycerin or glycerol, which is one of the few of the alcohols. I do want you to know the common name as well. What's its IUPAC name? So this introduces us to another rule. We would still want to do what's the longest carbon chain. So it's 3. So that would be propane if it were saturated. But one of the unique things you'll notice is I have more than 1 hydroxyl group. So that leads us to some new rules. If you have more than 1 hydroxyl group, you are going to keep the ending of the alkyl name. So that's talking about this. You're going to keep it and then add diol or triol as appropriate. So when I say keep the ending of the name, we're just not dropping the E in that case. So in that case, since I have 1, 2, 3 hydroxyl groups, I'm going to call this propane triol. But I'm not quite done because there could be some isomers of this out there with the hydroxyls in some different locations, so I do need to locate each one. So in that case, I have a hydroxyl group on each carbons, so the IUPAC name of this is 1, 2, 3, propane triol. You can see why we might like that common name just a little bit better. But if you have more than 1 hydroxyl group, you're going to retain that E. The only reason the E is retained is because of the way it rolls off your tongue. It's really just like the way you say it, because it's kind of nice to have that vowel there. And then you use di, tri, tetra, etc. to identify the number of hydroxyl groups you have. So I encourage you to pause the video and do some quick practice of naming some structures. One thing to ask yourself when you go to name